my channel. So today I'll be discussing with you all the 2019 January Physics Unit 1 paper. So let's get in. Question number 1. Which of the following is a vector quantity? So vector quantity means they have both magnitude and direction, and the other one is scalar. So it has only a magnitude. So here if we take work done, it only has a magnitude. Work done doesn't have any direction. Time is also, it does only have a magnitude. That means it only has a value. Then temperature, it also only has a value. There is no direction. But displacement is, it both has a value and a direction. Therefore displacement is the answer, D. Question number 2. Which of the following is equivalent to 1 kilowatt per hour? So 1 kilowatt equals 10 to the power 3. That means the easiest way to remember is deca, hecto, kilo, mega, giga, tera. So according to that order, 1, 2, 3, 6, 9, 12. So the other one, the minus values is uh, deci, centi, milli, micro, nano, pico. So then -1, -2, -3, -6, -9, -12. So you just, like, when you get the paper, like obviously you will get conversions. Therefore you take a pencil and write it. Then it's easy for you to remember. So you know how to like convert, because it's really hard to remember all the conversions. So when you remember like that, then it's easy for you to like, okay, okay, this is this, like that. So that's how I do my papers. So 1 kilowatt means 10 to the power 3. Then 1 hour has 3600 seconds. So we multiply 10 to the power 3 by 3600. So we get 3.6 into 10 to the power 6 joules. Okay, so the answer is C. Then question number 3. Stokes' law can be used to determine the frictional forces on an object moving through a fluid. To which of the following would Stokes' law best apply? So this is a question related to theory. So when it comes to Stokes' law, it should be a small sphere. We know that, but then the small sphere is moving in constant velocity. That's the conditions when it comes to Stokes' law. Therefore, D is the answer. Small sphere moving slowly through a fluid. Because if a small sphere is moving quickly through a fluid, it cannot have a constant velocity. But if it is moving slowly, then it can have a constant velocity per unit time. Therefore, D is the answer. Question number 4. A force of 90 Newton is used to push a box along a ramp of length 10 meters up to a platform. The platform is 4 meters above the ground. The weight of the box is 200 newtons. Which of the following expression could be used to determine the efficiency of the ramp? So efficiencies here is useful energy output divided by total energy input. That's the efficiency equation. But efficiency is all about the energy. So here the energy is work done. Okay, so the equation for work done is force into distance. Therefore, we take the horizontal work done and the vertical work done. Okay, so we multiply 200 by 4 meters, 200 newtons by 4 meters. That is the vertical work done component. And the horizontal one is 90 newtons multiplied by 10 meters. So then we divide 200 newtons multiplied by 4 meters divided by 90 newtons into 10 meters. So they are not telling us to get the final answer. They are only telling us to write the correct equation. So therefore C is the answer. Question number 5. According to Newton's third law, when two objects interact, they exert forces on each other. Which of the following statements is not a correct description of these forces? So we know the Newton's third law is every action has an equal and opposite reaction. It has equal and opposite reaction. For example, if we take two people, okay, they are going towards the same direction. Okay, so then if they collide, then there is equal and opposite reaction. That means the collision, that person collides to the next person and that person collides to that person. Therefore that's the equal. But when after collision they move to the opposite directions, because due to the pressure of the collision, so then opposite reactions. Okay, so that's the example I gave you just to understand. So here I have drawn two squares. So you can see it's going like the first square is going to the right side and the second square is going to the left side. Okay, so now let's take a look at the suggestions they have given us. A is the forces act at the same time. Yeah, it's correct, because now, for example, here when the two squares collide, the forces act at the same time because they are colliding. They are coming in the same speed. They are coming in the same direction. So they collide. The forces act at the same time. Okay, so when one square acts a force on the other square at the same exact moment, the next square, the other square also acts its force on the other square. So B says the forces act in the same direction. So that's the answer. So let's take a look at others as well. The forces act on different objects. Yeah, that's true. The forces act on different objects. The forces have the same magnitude. Yes, the forces have the same magnitude. That's really an important point, especially when it comes to calculations. You can get calculations like this as well, referring to Newton's third law. So you must remember that the magnitude will always be the same. Okay, so the answer is the forces act in the same direction, because it's not correct, because the forces does not act in the same direction. Because now here, now the square that is coming from the left side, it will, the force it acts on the square is to the right and the other one is to the left. So therefore the forces act on the opposites. Okay, so it's acting on the opposite direction to it comes. Okay, so the answer is B. Question number 6. A ball is thrown vertically upwards. Which row of the table correctly describes the magnitude of the initial acceleration of the ball and the magnitude of the acceleration when it is at its maximum height? So here we can see they are saying the ball is thrown vertically upwards. So that means someone is throwing the ball. So here, see, I have drawn a diagram for you all to understand. Okay, someone is throwing the ball. So when someone is throwing, so if we take our hand and if we take the ball like in this diagram, we are holding it from the ground. So therefore gravitational field strength act on the ball, and obviously when the ball is thrown upwards, gravitational field strength acts again. Therefore the answer is C, because initial acceleration is also 9.81 ms minus 2. That means the gravitational field is acting on it. Okay, and then acceleration at maximum height is also 9.81 ms minus 2. Okay, so I hope you understand. But if they say the ball is thrown from rest, or if the question is the ball falls from rest and reaches its maximum height, then it's zero, then the initial acceleration is zero. Okay, but it's here, it's not like that. The ball is thrown vertically upwards. So thrown means obviously someone is holding it. So therefore gravitational field strength acts. Okay, then question number 7. One end of a 50 centimeter length of wire is attached to a support. A load is attached to the free end of the wire, which extends by 2 millimeters. So mark it. 50 centimeters is the original length, and the extended extension, the extended is 2 millimeters. We extend it to 2 millimeters. Which of the following is the strain for the length of the wire? So strain, the equation for strain is extension divided by original length. Okay, so basically it's, now if they give us two lengths, then we need to find the difference between the two lengths and then divide it by the original length. But here they have given us 2 millimeters. They have told us which extends by 2 millimeters. Okay, therefore it's millimeters, so we need to convert into centimeters. So we multiply 2 by 10 to the power minus 2 and divide it by 50, and we get 0.04. So the answer is A. Question number 8. A ball is dropped, bounces once, and is then caught. Okay, which of the following graphs of gravitational potential energy against time could represent the motion of the ball? So a ball is dropped. Okay, so that means it, gravitational field strength acts on the ball like the earlier question. Okay, it's not at rest, and then it bounces once. So bounces means it reaches the ground, so it becomes stationary for some time, for a particular time, for a small period of time, and then it's again caught. Okay, so the answer is A, because it starts from it already, someone is bouncing it, therefore gravitational field strength affects the ball. So then once it reaches the ground, it's zero, it's stationary. So then the gravity, there's no gravitational field acting on it, therefore it's zero, it comes to rest, and then again it's caught. So when it comes to its original position, or once it comes to originally to the person's hand who dropped it, then again gravitational field strength affects during that process. Therefore A is the answer. Okay. And also now it's about accelerate. We can see like here C. Now if now there's you must the problem comes between A and C, because B and D obviously it's not correct, but C you can see it's a straight, it's more linear. So actually when a ball is dropped it cannot be like that, because here it's all about acceleration. Okay, so in acceleration the velocity can either increase or decrease, because acceleration is all about that, the change in velocity. Okay, if it's constant velocity then there is no acceleration. Okay, resultant forces are zero, so there is no acceleration, so then it can be C. But acceleration is all about, the definition of acceleration is change in velocity. Okay, therefore that's why the answer is A and not C. Okay, question number 9. The stiffness constant and the Young modulus are terms used in physics. Which row of the table shows the correct application for these terms? So the answer is D, because stiffness constant applies to objects and Young modulus applies to materials. So the thing here is stiffness means, for example, if both the stiffness name means like how we can stretch the object, how we can stretch, or like even it doesn't matter what the object is. For example, if both the objects are made from steel, okay, it doesn't matter, because it's all about stretching the object. Okay, but then Young modulus it affects on materials, because what type of material it's made of. For example, if there are two wires, but one is made from a really very strong metal and the other one is made from a soft metal, so then the soft metal it can easily be, it's flexible than the strong metal. So Young modulus it affects on what type of material it is, but stiffness it does not affect. Okay. Question number 10. A student uses a balance to measure the mass of a small cube with sides of length x. The student also measured the mass of a large cube with sides of length 1.5x. Which of the following is the density PL of the larger cube in terms of the density PS of the smaller cube? So density, the equation for density is mass over volume. So density of the small cube, the mass for both the masses are same, 50.0 grams. Then volume is x cube, because length is given as x. So volume is anywhere the length of the side cubed. So it's x cube. Then density of the large cube is 50.0 divided by 1.5 x cube. Okay, and then to find the density of the large cube in terms of the density of the smaller cube, we must divide the large by the small one. So 50.0 divided by 1.5 x cube should be divided by the density of the smaller one, 50.0 divided by x cube. So then the answer is 30.0. So D is the answer. Okay, section B. Now we have come to the section B of the paper. Question number 11. The graph shows how the velocity of an object varies with time. Describe how the acceleration of the object varies with time. Your answer should include calculations. So we can see starting from the rest. Okay, it's a velocity time graph. Starting from rest, the object is slowly accelerating. It's slowly accelerating, but once it reaches 9 seconds, the acceleration becomes negative. From 9 to 12 seconds, the object is decelerating, and from 12 to 17.5 seconds, the object is decelerating while going in the opposite direction. Okay, so that's the answer. Then question number 12. A student carries out an experiment to determine a value for g. The acceleration of free fall. A short wooden rod is released above a light gate. A timer connected to the light gate is used to measure the time taken for the wooden rod to pass through the light gate. The experimental agreement is shown. So this is the experimental, like this is the diagram which is used for the above experiment. The student uses the equation v squared equals u squared plus 2as, where u is o, that means, u means initial velocity, which is 0, and a graphical method to determine a value for g. A. State the additional measurements the student should take. So, length of the wooden rod, the student must measure the length of the wooden rod and the distance from rod to the light gate. So, those are the two other measurements, because time is there, and then it's starting from rest. So, we know initial velocity is 0, and we are measuring here v. So, therefore, the two remaining things is length of the wooden rod and distance from rod to the light gate. Part B. Describe how the velocity of the wooden rod changes as it passes through the light gate can be determined accurately. So, we should take V equals length of rod divided by time. So they are asking how to get the velocity. So we can get the length of rod divided by time. Repeat the same thing at each height and calculate the average. So they are asking how we can get accurately. So we must take the length of rod and time, and then we must subject V and divide length of rod by time, and we can take at each height we must do the same thing, repeat the same thing, and we can get the average. So then it's more accurate. C. Describe how the student can determine a value for G using a graphical method. So they are asking how to get the value for G using graphical method. So I have written it in 1, 2, 3 form so that you can understand. But then actually for the paper, when you are writing it, you must write it in paragraphs, because for point form they don't give marks. You must write it in paragraphs. But here I wrote it in 1, 2, 3 forms, because then you all can remember, because these questions are related to the practicals you have done in physics unit 1. Therefore, I gave it in 1, 2, 3 form because it's easy for you all, and for me as well. So because of that. So, 1, measure the length of the wooden rod. So, first of all, we must measure the length of the wooden rod, and we must measure the time for the rod to pass through the light gate. Okay, so then we get we must divide the length by time and measure the speed for the wooden rod to get to the light gate from the starting point. Okay, and then we have V and S speed. Then we repeat the experiment for several different release heights so that several values can be taken. Okay, and then we should calculate V squared. Okay, so V squared equals U squared plus 2AS. So U we know it's 0, therefore um, um, we know the V value, so V squared, and then we know the speed. So then we must plot a graph V squared versus speed S, and then um, v squared equals 2gs. Okay, instead of a we put g, that means gravity. Then the gradient is gravity divided by 2. Therefore you can get g using a graphical method. Okay, question number 13. Two brackets A and B support a shelf of length 1.2 meters. Bracket A is positioned 1.5 meter from the left end of the shelf. A book is placed 0.35 meters from the left end of the shelf as shown. So I have underlined the important points here, okay, because the points that are needed to do our calculation, which is coming in now. A. The normal contact forces of each bracket on the shelf are equal. Determine the distance from bracket B of the left hand end of the shelf. So we need to find this. This is the line I have drawn it. This is the part we need to find here. Okay, this. So they have given us the weight of the book, which is 8.5 newton. So obviously that is the force that is acting on the book, downward force. Then they have given us the weight of the shelf, it is 14 newtons. Okay, and also they have given some other information in the question itself. So now let's see how to get the final answer. So the shelf is uniform, so we divide 1.2 by 2, because now the shelf is uniform, so then we divide 1.2 by 2, and then we get 0.6 meters. So from the place where the weight is acting, okay, let's take the place as here. Now from here weight is acting, okay, and then this part is 0.6 and this part is 0.6, okay, it's divided, okay, then one part is 0.6, one part is, for example, if I take here O, I drew alpha. So from alpha to A, the distance is 1.6 meters of the shelf, and from alpha to B, the distance is 0.6 meters. I'm really sorry. 1.2 is the full length of the shelf. The full length is 1.2. Okay, but from now, since the shelf is uniform, we divide 1.2 by 2. So then alpha to A is 0.6, alpha to B, not only alpha to B, from alpha to the ending part which we are going to find, okay, plus B is 0.6, okay. Okay, now that's the first calculation I have done. Then we use the vertical forces, okay, and then total weight equals 14 plus 8.5, okay. The total weight here, now we have the book and the shelf, so the total weight here is 22.5 newtons, okay. And then since forces of A and B are equal, the R means the normal contact force of is equal to B. A of R is equal to B. So 22.5 divided by 2 equals 11.25 newtons. So the forces that is acting on A and B are both equal. Therefore, the normal contact force which is acting on A is also 11.25, and the force that is acting on B is also 11.25. Okay. Now here we have taken the weights as forces. Since it's Newton, it's forces. Okay, it's just a weight, so you don't have to like. It's like confusing, but then you must understand it. When you practice more, like, then you will be able to do the questions. Then we take the moments about bracket A. So this removes R of A, and so let X be the distance of the left end to bracket B. Okay, so then X minus 0.15, because they have already given us the moment in bracket A. Therefore, bracket A, they have given the moment. Therefore, the distance of the left end to bracket B becomes X minus 0.50. Okay, then since clockwise moment is equal to anti-clockwise moment, shelf equals 14 into 0.6 minus 0.15. Okay, so 0.6 is, I told you, I divided the shelf is uniform, and I divided the from the center of weight of the shelf, I divided the distance, so we minus it by 0.15, okay, to find the moment of the shelf. So then it's 14 into 0.45, okay. Then the book, it's 8.5 into 0.35 minus 0.15, okay, because they have already given us the distance of the book, 0.35 meters. Then it is 8.5 into 0.20. So then we add 14 into 0.45 and 8.5 into 0.20, and then it's 8.0. Then we then we apply the same principle, and 11.25, okay, which is the total weight force of both the book and the shelf, we multiply it by X minus 0.15. X is the unknown distance of bracket B to the left end. Then it is equal to 8.0, because 8.0 is the total moment, okay, of the shelf and the book. So then we we subject X minus 0.15 and equally to 8.0 divided by 11.25 equal to 0.711, and then when we subject X and finally get the answer, it's 0.86. So the distance is 0.86. So if you want to find out whether your answer is correct, you can redo everything, because now they are asking us to find, so moment is moment is normally force into perpendicular distance from pivot. So b, you take b as the pivot, and you know the you know the force is equal. Take the distance and find the moment. Okay, so now this distance is 0.86, you got it. And then you need to find you know the force, and you know the force. So then you can substitute the answers and find out whether, like you can do this overall, so to find out whether the values they have given in the question comes. So if the values that are given in the question comes, then it's easy for you, then you can, you know that your answer is correct, or else you have to again try it. Okay, part B. Bracket B is moved closer to the left hand end of the shelf. Explain the effect on the magnitude of the normal contact force of bracket B on the shelf. So, left hand end means this one, this side. Moved more to this side. Okay, if B is moved more to this side. So, they are asking, explain the effect on the magnitude of the normal contact force of bracket B on the shelf. So, when bracket B is moved further away from bracket A towards the left end, the distance, yeah, here we must take it as this, like this side, not this side. Left end, the distance between decreases. In order to keep the shelf at equilibrium, the normal contact force should increase. Okay, we take the opposite here. Even I got messed up here. It's actually this. It's opposite this side. Okay, so left means this side here. 14. The approximate age of an egg can be determined by placing it in a bowl of water. Two eggs of different ages are placed in water and come to rest as shown. So here we can see the egg which is 1 day older goes to the bottom, and the old one which is 1 month, um, it sinks. The internal structure of an egg is shown below. So here they have shown us the internal structure of an egg. Okay. Then a student searched on the internet to find the reason why old eggs float. He found the following statements on different websites. Statement 1. Old eggs float because as the egg ages, it starts to decompose. As it decomposes, gases are produced that escape through the eggshell. Okay. Now, at a glance, when we read the statement 1, it shows us that statement 1 leads to an increase into a decrease in weight. Yeah, escape means to a decrease in weight. Okay, so that means the weight decreases. Then statement 2, as this egg ages, air enters the egg through the eggshell and increases the size of the air cell. The larger air cell acts as a flotation device, and hence old eggs float. Okay, so in statement 2 they says the air enters, therefore it leads to an increase in weight. um, Yeah, enters. So statement 1 says a decrease in weight. Statement 2 says an increase in it. Okay. So the question is, assess which of these two statements is correct. Okay. So the answer is statement 1 leads to decrease. Now here you must link these two statements to the diagram they have given. They have already given us that 1 day and 1 month what happens to the eggs, how whether they float or whether they sink. Therefore we need to link statement 1 and statement 2 to that. That means what you should do is, they have given us to like compare. So by using the given diagram only, we must decide whether statement 1 is correct or statement 2 is correct. Okay, so statement 1 leads to decrease in the weight of the egg because air escapes. Okay, because air escapes, therefore statement 1 leads to decrease in the weight of the egg. Statement 2 leads to an increase in the egg weight because air enters. In the above conditions, volume and the force upthrust remain same. So therefore, volume and the force upthrust have nothing to do um, with the rising or sinking the egg. In order the egg to rise, okay, so here we know that it's 1 month. So like actually you must take this get the help of the diagram to answer the question. That means you use the diagram as proof, and then you find out whether statement 1 or statement 2 is correct. So according to the diagram, okay, it's done practically. So according to the diagram, all the egg will rise. So in order the egg to rise, weight should be smaller than upthrust. To sink, weight should be bigger than upthrust. So according to the diagram shown, the old egg